In this video, we'll talk about how to solve these problems using binomial probabilities. Now, first of all, we need to know how do you know that you can use binomial probabilities? So we have a little checklist. So, for binomial probabilities, there has to be a fixed number of trials, first of all. And if we look in each of these problems in 45, it says if 20 North Americans are randomly selected, blah, blah, blah. So the 20 North Americans would be your fixed number of trials, and you have that in each of these problems. So that works. The trials have to be independent. So we are selecting a group of people, and we don't have any indication. We're selecting North Americans, so if we're selecting them randomly, there would be no reason why one person being selected would affect whether the other person was on Facebook. Of course, if we were selecting from maybe just a small group of people in a town, then we wouldn't necessarily have that independence, but we can assume that independence here. Okay, the probability of success is the same for each trial. That's given in the instructions here, where it says a 2017 study found that 72.4% of North Americans are on Facebook, so that probability remains the same. And each trial results in either success or failure. So we're checking with each of these individuals, and either they're on Facebook or they're not on Facebook. So we would have just those two possibilities there. And if you had somebody who said, well, I was on Facebook, but now I'm not anymore, you'd have to just decide which category they belonged in under those circumstances. So there's definitely either just success or failure here. So we've got all our conditions for using the binomial probability distribution. So now how do we solve these individual problems? Let's start with number 45. In this question, it says, if 20 North Americans are randomly selected, what is the probability that exactly 15 of them are on Facebook? So we're finding the probability of exactly 15 successes. And in order to calculate this using your graphing calculator, you would use the binom PDF function. And in order to access that, what you're going to do is press second and the vars key, or variables, and then you can scroll down or scroll up, whichever, and you're looking for binom PDF in this particular problem, and in the other problems we're going to be using binom CDF. Because this is just one individual value that we're looking to find the probability for, that's why we're using binom PDF. If ever it's a range of values, then we use CDF. So PDF is for individual value, and CDF is for a range. All right, so we're using the binom PDF function, and it will ask you for the number of trials. So in this case, that's 20. And probability of success for an individual trial is 0.724, because that's the 72.4%. And the number of successes we're looking for is 15. So when you enter that into your calculator, we get 0.1955, and that's my final answer. So that's how we find a probability for one individual value using the binomial distribution. Now let's take a look at 46. In this one it says, if 100 North Americans are randomly selected, what is the probability that fewer than 60 of them are on Facebook? So we're not looking for, say, the probability of 60. We're looking for the probability that whatever number it is less than 60. So we want to go anywhere from 0 to 59 successes, because fewer than 60, so that has to be ending at 59. So when we use the binompedia function in 45, we use the number 15. That was our value here. Now, when we're using the binomcedia function, because this is a range of values, first of all, I need to say what is the number of trials, and that's 100. Probability of success is 0.724. And now, what is the maximum number of successes? So we have to have this in the format of 0 to whatever number. And whatever number that is, in this case is 59, that's our x value here at the end. And when we calculate this, we get 0.0026. Now, it also asks, would it be unusual for fewer than 60 out of 100 North Americans to be on Facebook? Since this is a very small probability, it's less than 5%. So yes, this would be unusual. And that solves that problem. So that's a pretty straightforward problem. Now let's take a look at 47. Oops, 47. And this is a little bit more complicated. So in this one it says if 300 North Americans are randomly selected, what is the probability that more than 200 of them are on Facebook? Now here's why this is a little bit more complicated. Because we're going to calculate the probability, it said more than 200, so that means we can start at 201 and go all the way up to the maximum number of people that we have. We can't have more than 300 because we only selected 300. So it's 201 to 300. The calculator won't find this. The calculator only does 0 to a particular number. So we need to convert this, and what we can do is say, well, instead of 201 to 300, we're going to use the complement. We're going to say, well, what's the opposite of 201 to 300? Well, that would be 0 to 200. Notice that we were starting at 201 here, and what I want to do is find what is basically the other group. This would be 201 successes all the way up to 300, and the other group of possibilities would be anywhere from 0 to 200. No overlap, because 200, 201 don't overlap with each other. So we want to make sure we don't miss any. I don't want to go like 199, and then where are the 200 successes? So we make sure that we have this group, doesn't overlap with this group at all. And we're using 1 minus because it's the complement. So, how I enter this into the calculator, and I like to just start off by typing in 1 minus first of all, and then you can press second vars and go into that binom CDF, and it'll ask you for the number of trials, which is 300 in this case. Probability of success, still 0.724. And our maximum number of successes is the 200. So when I calculate that, I get 0.9832. That's my number of successes, and since this is greater than or equal to 0.05, we would say this is not unusual to get more than 200 out of 300 randomly selected people. All right, let's take a look at 48. Fairly similar to 47. In this one, it says if 150 North Americans are randomly selected, what is the probability that at least 120 of them are on Facebook? So I always like to start off with this. I think it makes it a lot easier rather than trying to memorize, oh, when it says more than, then I do this. And when it says at least, then I do this. I don't even worry about that. I just look at, so if it says at least 120, that means that we're starting at 120. And we're going up to what? 150 is the maximum. And since this doesn't start at 0, then I have to make this 1 minus the probability of 0 to what? Well, what's the number right before 120? 119. And there you go. So, this is 1 minus binom CDF. Once you have that, once you have this 1 minus probability of 0 to 119, this is going to be very easy because you're just doing the same thing as normal. Just make sure you put in that 1 minus and then do your binom CDF and enter in the information. So, our number of trials is 150. Probability of success is 0.724. And maximum number of successes, 119. And this comes out to 0.0207, which is less than 0.05. So I would say that would be unusual. Okay. And now one more, 49. In this problem, it says if 240 North Americans are randomly selected, what is the probability that at most 170 of them are on Facebook? So, we're finding the probability of anywhere from 0 to 170. And do I have to do the 1 minus? I don't, because it's already starting at 0 to whatever. So I like to call that calculator ready. So we're ready to put that in, and we're going to do binom CDF. And number of trials, oops, it's not 170. What is it? 240. Okay, so number of trials is 240, probability of success is 0.724, and our maximum number of successes is 170. And that comes out to 0.3160, which is greater than or equal to 0.05. So we would say this would not be unusual. And that's how you do those problems.